Today we are going to start with the new topic, that is the binomial theorem. First of all, I will teach binomial theorem according to our textbook, and then we will look at the entrance point of view, extra additional thing in the NCERT and for the JEE mains. So first of all, we start with the topic, that is a basic definition. What does exactly mean? So binomial theorems means what? Bi means two. There is two terms, therefore it is called as a binomial theorem. So there are expressions which you know, a plus b raised to 1. So what is that? A plus b. A plus b the whole square. What is that? It is a square plus 2ab plus b square. Similarly, a plus b the whole cube. What is that? It is a cube plus 3a square b plus 3ab square plus b cube, like this. So now, what will be a plus b raised to 4? What will be the a plus b raised to 4? Can you write a plus b raised to 4? What should be a plus b raised to 4? If you look at this, you will find that a plus b raised to 4 is equals to a raised to 4 plus 4a raised to 3b plus 6a square b square plus 4ab cube plus b raised to 4. If I know the previous expression, I can easily write what is the next. So how to write that next? How we got this one? So there is very simple thing in this. Have I got this one? It's very simple thing in this. If you look at this, the sum of the coefficients are 1, 1 in this. It is 1, 1. After that, the coefficient become 1, 2, 1. 1, 2, 1. Next is 1, 3, 3, 1. It is 1, 3, 3, 1. So how this coefficient we are getting? Basically, the sum of these two, 1 and 1 will give the 2. That is called as a Pascal's triangle. The Pascal's coefficients. So what is the Pascal's triangle here? The student, the Pascal triangle is, if you write 1, 1 as a coefficient in the first expression, the second expression is the sum of these two, that is 2, and again the last is 1, 1. The next is sum of these two, that is 3, 3, and again 1, 1. Next coefficients 1, 4, 6, 4, 1. That is sum of these two is here, sum of this two is here, sum of this two is here, like that. The same, we look at the coefficient 1, 4, 6, 4, 1. So you get that value here, 1, 4, 6, 4, 1. So you will get that coefficient from this triangle. And if you observe the power of a here, the power of a is a raised to 1, the next is a raised to 0. In the second expression, for a plus b the whole square, it is a square, a raised to 1, then a raised to 0. The power of a decreases. Here it is a cube, a square, a raised to 0. A raised to 4, a cube, a square, a, and a raised to 0, like this. The power of a goes on decreasing, and the power of b is increasing. It is b raised to 0, b raised to 1, 0, 1, 2, 0, 1, 2, 3 for b power, 0, 1, 2, 3 and 4. That is the power of b is increasing. So with the help of this, can you write what is a plus b raised to 5? Yes, dear student, you can write easily. What is a plus b raised to 5? the power of A will goes on decreasing and the power of B will goes on increasing. So first term is always A raised to 5. The next is A raised to 4. Next, A raised to 3. A raised to 2. A raised to 1. And the last is A raised to 0. A raised to 0. But A raised to 0 is what? 1. So there is no need to write the term A raised to 0. It is the same as 1. Similarly, here it is B raised to 0. B raised to 1. B raised to 2. B raised to 3. B raised to 4. And the last is what? B raised to 5. Again, B raised to 0 is 1. So there is no need to write that term. So the power of A decreases. Power of B increases. Like this. What is the coefficient? Coefficient will take from the what? The Pascal's triangle. What is that? The sum of these two, that is 5, 10, 10, 5, and the first and last is 1, 1. So here it is what? 1. The next is 5, 10, 10, 5, and that is 1. So the power, this expression is like this. It is A raised to 5, 5 A raised to 4B. 10 A cube is B square, and like this. So using this, we can easily write even A plus B raised to 6. So this particular expressions in which the two terms are involved and their power, the expression is called as a binomial expression. It's called a binomial expression. So what is a binomial theorem? When you write the same thing in general formula, then it is called as a binomial theorem. So what's the binomial theorem, dear? What's the binomial theorem, dear student? So remember that the same theorem, same expression, if you write in general, then that particular formula which is valid for any power, the n is anything, the particular formula is applicable. In that case, that is called as a binomial theorem. So here, the Pascal triangle will give you 1. The 1 is nothing but 1C0. The next one is 1C1. Similarly, it is 2C0, 2C1, 2C2. So what is this? It is 3C0. Yes, it is 3C1, 3C2, 3C3. But basically these expressions are nothing but this is 5C0 value, this is 5C1, 5C2, 5C3, 5C4, and this is 5C5, like this. So this expression is here. In this expression, can we write the general formula for A plus B raised to n? Yes, we can write the general formula for A plus B raised to n. What is that? If the first term here, if you observe, is always 0, then 1, then 2, and then whatever the power is there, that is there. So it is, we can write this as NC0, A power, that is A raised to n, plus NC1, A raised to n minus 1, B raised to 1. Plus NC2, A raised to n minus 2, B raised to 2. And similarly, it will be the power of A decreases, power of B increases, power of B here is 0, then 1, then 2. The power of B increases, power of A decreases, and the coefficients are NC0, NC1 like this. So last term will be what? It is NCn, B raised to n. So this particular expression, this particular formula is called as binomial theorem. This particular formula is called as binomial theorem. So that is the formula for binomial theorem. Understood, student? It's a very simple concept and very simple formula, and we should know how to find what is the coefficient for the higher power. If the power is very large, then we should know how to find NC0 value, NC1 value, NC2 values. So how to find that values here? How to find the values? We'll go with that. Remember that the NC0 is always equal to what? 1. NC1 is n. NC2 is n minus 1 upon 1 into 2. That is 2 factorial, we can say. So generalized NC3 is n minus 1 n minus 2 upon 1, 2, 3. So what is the formula? NCR is equal to what? What is NCR? It is n factorial upon r factorial into n minus r factorial. So it's like this. NCR is given by n factorial upon r factorial into n minus r factorial. So this is a formula to find out the NCR. So what's the binomial expression? What's the binomial formula here? So binomial formula is a plus b raised to n is nc0 a raised to n plus nc1 a raised to n minus 1 b raised to 1 nc2 a raised to n minus 2 b raised to 2 like this ncn b raised to n. So this particular expression is called as a binomial theorem. Hello. So a minus b raised to n, what will be that? Because a plus b is like this, so same expression nc0 a raised to n nc1 a raised to n minus. Now here, now b is basically you have to replace with minus b. The reason is this expression can be written as a plus minus b raised to n. It is the meaning of this. That means the same formula, but only the b is replaced by what? Minus b. The rest is same. So because of that, what happens? C. So the next term will be what? nc2 a raised to n minus 2 minus b square and so on. So the last term will be what? ncn minus b raised to n. So clearly from this, when the power of minus b is odd, it will be negative sign. When the power of minus b is even, it will be what? Positive sign. Therefore this expression becomes nc0 a raised to n minus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b square and so on. So that means there is alternate plus then minus and plus then minus, like this expression will come when the power when this sign of b is opposite, that is minus b. When the b is replaced by minus b, then this becomes like this expression. This alternate plus minus sign will come, and therefore ज़्यादा टेंशन लेने की बात नहीं. There is no need to just remember this formula, but remember that whenever there is b is replaced with minus b, there is alternate plus minus sign. The reason behind is this: that is, when there is an odd power, it will be negative. When there is an even power, it is positive in the expression. Now, textbook sums. Exercise 4.2 in your textbook. First question here. Question number 1 is prove that or show that root 3 plus root 2 raised to 6 plus root 3 minus root 2 raised to 6 is equals to 970. This you have to prove. So in this case, first of all, we will find the expression for this. Root 3 plus root 2 raised to 6. So what is that? For that 6 power, we have to use the 6 power Pascal's triangle formula here. So what is the Pascal triangle for 6 power? 1, 1. Then you have to add this 1, 2, 1. The next 1 plus 2 is 3. like this. 1, 3, 3, 1. Next, 1, 4, 6, 4, 1. Yes, here. This is right. 1, 5, 10, 10, 5, 1. Next is 1, 6, 15, 20, 15, 6, 1. So this is our coefficient for the sixth power. That is 1, 6, 15, 20, 56, 1. So now we will use this one to find the expression for this. The power of the given that the power of the first term goes on decreasing and the power of the second term will goes on increasing. So here for this, root 3 plus root 2 raised to 6, that will be what? The power of the first term goes on decreasing. So it is root 3 raised to 6. Next, look at the coefficient. The next coefficient is what? 6. Decreases the power. Root 3 raised to 5. Next, root 2 raised to 1. After that, 15. Root 3 raised to 4. Root 2 square. Next, 20. Root 3 cube. Root 2 cube. Plus 15. Root 3 square. Root 2 raised to 4. Next, 6 root 3 into root 2 raised to 5, and the last is root 2 raised to 6. So that is there. So look at the coefficient 1, 6, 15, 20, 15, 6, 1. So it is there 1, 6, 15, 20, 15, 6, and then the last is 1. The power of root 3 is 6, 5, 4, 3, 2, 1 and then 0. The power of root 2 is root 2 raised to 0, root 2 raised to 1, root 2 square, root 2 cube, root 2 raised to 4, root 2 raised to 5, root 2 raised to 6. That is always the power of the first term decreases, power of the second term increases, and the coefficient will come from where? From the Pascal's triangle. So like this. So now root 3 raised to 6. So what is the root 3 raised to 6? You have to multiply root 3, root 3, root 3. How many times? 6 times. So what is that? When you multiply root 3 into 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 root 3. How many times? 6 times. So it is 3 into 3 into 3. That is equal to what? 27. So root 3 into root 3 6 times. So we give the 27. So first one here it is 27. Next 6 into 9 root 3 into root 2. After that it is 15 into 9. It is 15 into 9 and root 2 square, that is 2. After that, it is 20. Root 3 cube is 3 root 3 and that is 2 root 2. Here it is 15 into 3 and that is 2. It is 6 root 3 into root 2, sorry, it will be 4. And next will be what? 4 root 2. And the last is 8. So this is expression. Now we calculate the values. So first value will be what? 27 as it is. 9, 6 into 9 is? It is 54. Root 3 into root 2 is? Root 6. Next, 59 is 135. 135 into 2. 135 into 2 is 270. This is 20 into 3, 60, 60 into 2, 120, so it is a 120 root 6. 15 4s are 60, 60 into 3, it is 180. This is 24 root 6. And the last is 8. So this is an expression for root 3 plus root 2 raised to 6. Similarly, we can write the expression for root 3 minus root 2 raised to 6. We can write this as similarly. How to write this? Because there is alternate plus minus will come. So you can write this as 27 minus 54 root 6 plus 270 minus 120 root 6 plus 180 minus 24 root 6 plus 8, like this. Now adding 1 and 2, adding 1 and 2, we will get what? Okay, add 1 and 2, we will get LHS. So what's LHS here? Root 3 plus root 2 raised to 6 plus root 3 minus root 2 raised to 6. So adding this to, clearly here 27 the same sign, so it will be double because the opposite sign 54 root 6 and minus 54 root 6, so it will get cancelled. So it will get cancelled. So expression will be what? Whenever it's the same sign, it will be double. So it's 2 into 27. The rest will get cancelled. So 27 plus 270 plus 180 plus 8. So this is the remaining expression for this 27. So it is 2 into 27 plus 8 is 35, and this is 350. This is 450. 450 plus 35, so this becomes 485. And 485 multiplied with 2, that will give you what? It is 970, and that is your right hand side. So it is proved because it's 420 485 is 970. So it is proved like this. So you can easily prove this one. So here it's very simple one. You have to just check the power of the first term decreases. The power of the second term increases, and for the sixth power, you have to take the coefficient from where? Pascal standard. So I think everybody should understand this one. So very easy, right? Now we move to the next sum. Yeah. Next one is question number 5. Find the value of 102 raised to 4 using binomial expansion. So 102 raised to 4 you have to find using binomial expansion. So it's very easy. 102 raised to 4 is 100 plus 2 raised to 4. You have to write like this. And then use the same concept for the fourth power. What is Pascal's coefficients? For the fourth power, what are the Pascal's coefficients? So it is 1, 1, 1, 2, 1, 3, 3, 1. Like this. Is 1, 4, 6, 4, 1. These are the Pascal coefficients. The power of the first term 100. So 100 raised to 4. The next is 4. 100 power increases, 2 power increases. Next coefficient 6. 100 power decreases, 2 power increases. Next is 4. 100 power further decreases, 2 power increases. Then the last is 2 raised to 4. So look at the coefficient 1, 4, 6, 4, 1. That is the coefficients here, and then the power for 100, 100 raised to 4, 100 cube, 100 square, 100 raised to 1. Power for 2, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and 2 raised to 4. So the expression is right. Now the calculation part. So 100 raised to 4 is there. So 100 raised to 4 is what? When you square it, you get a 2 zeros. So 2 0, 3, then you go on adding the zeros. That's it. So it is 2 zeros over square, cube, 4th power. Here 4 into 2 is 8 and 2, 2, 2, that will be 6 0 will come. Here 6 into 4, 24, and there will be 4 zeros will come. 8 into 4, that is 16, only 2 zeros will come. This 8 fours are, sorry, it is 8 fours are 32. 8 into 4 it is 32 and 2 raised to 4 is 16. So answer will be what? C. How to write this? 20202020. So it will come here. So it's 108 24 3216. So this is the answer for 102 raised to 4. So 102 raised to 4 is 108 24 3216. Next, question number 6. Find the value of 0.9 raised to 4. We find the value of 0.9 raised to 4 using binomial expression, the binomial theorem. So here 0.9, how to write 0.9? 0.9 you have to write as 1 minus 0.1. Right, so it is 1 minus 0.1 raised to 4. Again the same. So the power coefficient is same as the previous sum. That is 14641. So it will be what? 1 raised to 4. There are minus, because of minus it will be alternate, plus minus will come. So next is what? Minus 4, 1 cube, 0.1 plus 6, 1 square. 0.1 square, then minus 4, 1.1 cube plus 0.1 raised to 4. So because of minus, plus, minus, plus, minus, plus, that is there. The power of 1 should goes on increasing, goes on decreasing, 4, 3, 2, 1 and then 0. The power of 0.1 should be goes on increasing, 0.1, 0.1 square, 0.1 cube and 0.1 raised to 4 and the coefficient 1, 4, 6, 4, 1. So that is whatever the rules which for there for expression we all follow here. So the value is here 1, 4 into this, so it is 0.4. 1 minus 0.4. This is 0.06 because it's 0.01 and this is into 6, so it's 0.06. It is 0.001 into 4, so it is minus 0.004 plus 0.0001. So it is like this. So what is the value for this? I have to calculate. So what is the value? We have to add this 1.06, 1.06 0.1 and this is 0.404. So we can say this is 1.0601 minus 0.4040 like this. So what is this? 0 minus 4, that is 6, 5, 6, no, so it's 0.06561. That is a value for 0.9 raised to 4. So it is a very easy sum. It just goes on decrease the power 1 and increase the power for other. Next sum. Question 7 on this. And that is without expansion. Expanding fine. So what is the sum here? X plus 1 minus 4 6 minus 4 plus. So in this particular sum, we don't want to expand x plus 1 plus 4, x plus 1 cube and all this. Without expanding, we have to find this. So how to find this? You have to observe this particular sum properly. The coefficients 1, 4, 6, 4, 1. These are the coefficients here. And the first, and this. So this is exactly same of a minus b because atomic plus minus also there. So it is the a minus b raised to 4 power. So if you just compare this, say let x plus 1 is a and x minus 1 is equal to b in this. So we will get expression as a raised to 4 minus 4a cube b plus 6a square b square minus 4ab cube plus b raised to 4, which is nothing but what? A minus b raised to 4. And then put the value of a and put the value of b in this. What is the value of a? A value is x plus 1 and this is x minus 1. So raised to 4. X and x will get cancelled. 1 and 1 will add it. So it is 2 raised to 4. So answer will be what? 16, like this. So these are the sums, the basic sums of this binomial theorem using the binomial basic formulas or basic whatever concept we discussed till now, and we solved a few sums based on the board textbook. Now the same concept is valid for the JEE also. So we will solve now the question based on JEE mains, as well as when additional concept is there, it can be discussed during that particular questions, whenever the questions will come, and that we will discuss. So we will start now with JEE mains point of view. Solution of the first question for JEE mains. Question 1. That is, find the r plus 1 term. Find r plus 1 term in the expansion of x plus a raised to n. So x plus a raised to n, उसका r plus 1 term निकालना है. So how to find that r plus 1 term of this? So we know that it's simple formula here. It is given by T r plus 1 is NCR a raised to x raised to n a raised to like this. So that's the answer. So that is there in the option. Option 2. That's it. So option of terms x raised to n minus r, ratio of the coefficient of the term of x raised to n minus into a raised to r and x raised to r a raised to n minus r. So what is the coefficients ratios here? So when we'll get this ratio and when we'll get this one. So what is this term? So whatever the rth the power of, look at the power of A. The formula says, what is the formula here? Formula says that in A plus B raised to n, TR plus 1 is NCR, A raised to n minus R, B raised to R. So the power of the second term, whatever the second term power is there, that will be your R plus 1 term. With the power of the second term, that means this raised to R means this is what? This is, and that is a simple coefficient as well. That is the NCR. So here the coefficient is what? The coefficient of x raised to n minus R, A raised to R is equal to what? NCR, like this. Similarly, the coefficient of x raised to R, A raised to n minus R, what is that? So when R is here, the R goes here. So here it is NC n minus R, like this. And in permutation combination, there is a concept that NCR is always equal to NC n minus R. NCR is always equal to what? NC n minus R. Therefore, ratio will be 1:1. So the answer is ratio is 1:1. Like this. The coefficient of 7th and 13th term, coefficient of 7th and 13th term, 7th and 13th term in the binomial expansion, of a1 plus x raised to n are equal. Then what is the value of n? Here, what is the 7th term? 7th term is T7. And what is given by T7 is given by what? N. एक काम करना है because r plus 1 का value है. So this is therefore it is NC6 x first term, n minus 6 second term, it is x raised to 6, like this. And what is 13th term? So 13th term is T13, that is equal to what? NC12, 1 raised to n minus 12, and x raised to what? X raised to 12, like this. So that is the respectively the 7th and 13th term. So what we want to find, the both are equal. The coefficients are equal. Coefficients are equal. Coefficients are equal. Therefore, NC6 should be equal to what? NC12. And that is only possible when it is possible that we know that NCR is always equal to NC n minus R, like this. That means these two values should be the same, that is the sum of these two. So n is always equal to what? Sum of these two, that is 6 plus 12. So here n should be equal to 6 plus 12. Then this condition will be satisfied. So n should be equal to what? 18. So that's the answer for this sum. So look at the option. Option is third option is the correct answer for this one. So it is like this. Question 1, 2, and 3. Question 4. So what is there in the question 4? In the expansion of 1 minus x raised to 5, the coefficient of x raised to 5 will be, what is the coefficient of x raised to? Coefficient of x raised to 5 is what? That's the question. So in this expansion, what is the coefficient of x raised to 5? So the same, we will directly use a formula here. What is the formula? A plus b raised to n for a plus b raised to n. What is the NC? What is the TR plus 1? TR plus 1 is NCR, a raised to n minus r, BR. So here TR plus 1 is what? In the value of n is this, so it's 5CR. A is 1, so it is 1, 5 minus R. This is minus x raised to R, like this. So that is nothing but 5CR, 1 raised to 5 minus R, minus 1 raised to R, x raised to R. Now for coefficient of x raised to, for coefficient of x raised to 5, R should be equal to what? R should be equal to 5. So substitute R is equal to 5 in this. By substituting R is equal to 5, we'll get coefficient of x raised to 5 will be what? 5C5, 1 raised to 5 minus 5, and minus 1 raised to 5. So it is 1, 1, and this is minus 1. So answer should be what? Minus 1, which is there in the option. Minus 1, so it is option 2. So option 2 will be the correct answer for this. Now, move on to the next. So it is like this. Similarly, question number 5. Yes, so next, the question 5. Question 5, what is the question number 5? So number of terms in the expansion of 1 plus 5 root 2 x raised to 9 plus 1 minus 5 root 2 x raised to 9. So number of terms kitna hai? What is the number of terms? That's the question. So clear cut from, for this expansion, the number of terms will be what? T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 plus T8 plus T9 plus T10. Always there is one extra term. Whatever the power is there, power is n, then there is the n plus 1 term. So this is what? There are 10, and here it is minus. Because of minus sign, the alternate plus minus will come. So number of terms will be what? T1 minus T2 plus T3 minus T4 plus T5 minus T6 plus T7 minus T8 plus T9, and then minus T10. Plus minus plus minus plus minus plus minus plus minus, like this. And if we add it, so addition will give you what? It is 2 times, so T1 plus T3 plus T5 plus T7 plus T9. And since it is adding, so number of terms will be how much? Number of terms, the number of terms will be 1, 2, 3, 4, 5. This is the number of terms will be how much? 5. So right answer is what? So the number of terms remain 5. So answer is option 1 there. So option 1 is the correct answer. Yes, question number 6. Find 7th term from n. Remember that you have to find the 7th term from n. In expansion, x minus 2 upon x square minus 10. So in this case, the rth term from the n is always, in this expansion, a plus b raised to n, is always given by n minus r plus 2 term from beginning. So in this, if you want to find 7th term from n, the 7th term from n means it is 10 minus 7 plus 2. What is that? Term from beginning. So that's the question here. You have to find 5th term. That is, you have to find 5th term. So 7th term from n, matlab 5th term from the beginning. So what is T5 here? So T5 is equals to what? 10C4, that is NCR, because T is there. So n is equal to 10, so it is 10C4. X raised to 10 minus 4 minus 2 upon x square raised to 4. That is very simple formula in this. So answer will be 10c4 x raised to 6 minus 2 raised to 4 upon x raised to 8, which is nothing but 10c4. This is cancelled out, so it is 2 raised to 4 upon x square. So this is your final answer for question number 6. Question number 7. The question number 7 in this, what is the question 7 given? Question 7 is, if the coefficient of 2r plus 1, the coefficient of 2r plus 1, if coefficient of 2r plus 1 at term and r minus 1 at term and r minus 1 at term in the expansion of 1 plus x raised to 16 are equal, then what is the r? The both r coefficients are equal. So what is r? The r is equal to what? So again, r plus 1 in term. So what is t to r plus 1? It is ncr. Here n is 16, so that is 16 c2r. 1 raised to 16 minus 2r, and x raised to what? 2r. Like this. And then this one, so that is t r minus 1. So you have to further reduce one more. That is 16c r minus 2. 1 raised to, दोनों को subtract करेंगे, so that is 16 minus r, they become plus 2. That will be what? 18 minus r. Because you have to subtract this, look at that, this minus this, that is the formula, n minus r. So here this minus this, so that will become 16 minus r plus 2, therefore it is 18 minus r will come here. And here it is x plus 2 r minus 2, like this. So now the coefficients are equal. So what is the coefficient in this? If the coefficients are equal in this, so this is a 1, so there is no problem. Therefore, given condition 16c 2r should be equal to 16cr minus 2, and that can be done. That is, there are two possibilities when 2r should be equal to r minus 2, or 2r plus r minus 2 should be equal to what? 16. So this possibility will gives you r equal to minus 2, not possible. Not possible. The reason is because r should be, r is always positive integer, and here we will go this side, so 3r is equal to 18, so that gives you r equal to 6. So correct answer is r is equal to 6 is the for question 8. What is the question 8? The coefficient of 3rth power of x and r plus 2th power of x. Coefficients are equal in 1 plus x raised to 2n. Therefore, what we can say, this and this, we can simply add it, is equal to 2n. That is 4r plus 2 is equal to 2n. So n is equal to what? 2r plus 1. So that's the option. 2r plus 1. Option is option number 3. That's the correct answer for this sum. Next, question number 9. So yes. So question number 9 here, root 3 plus this 5 raised to 1 by 8, we can say, raised to 256. So this can be written as 3 raised to 1 upon 2 plus 5 raised to 1 upon 8 to 56. So now if you just expand this, it will be what? 256 C0 3 raised to 1 by 2 raised to 256. Next 256 C1 3 raised to 1 upon 2 raised to 1 5 raised to 1 upon 8. It should be raised to 255. Power reduces raised to 1 plus 255 C2. It is 254 5 raised to this and so on. So here, if you just observe this, this is 256 is divisible by 2. Therefore, the first term will be, this is an integral. Now here, this is not divisible, even this is also not divisible. So now when both will be divisible, is a clear cut. The LCM of 2 and 8 will be there. That is the power of this term is divisible by 2. Power of this term is divisible by 8. Then and then that particular term will be integral term. So that to happen, the power of 5 raised to 1 upon 8 should be power of 5 raised to 1 upon 8 should be multiple of 8. That is 0, 8, 16 and 256. And power of 3 raised to 1 upon 2 should be multiple of 0. Multiple of 2. That is 0, 2, 4, 6, 256. And if we combine both the conditions, whichever the case follow both the condition, that will be the integral term. Because not only this both conditions will be simultaneously satisfy होना चाहिए. दोनों simultaneously satisfy होगा, वही case होगा. So in this case, the power of this is 0, then it will be 256. So it is 0, 256. Next power will be what? 8. It will be 248. 16. Next 256 minus 16, it will be 240. So like this the power will come. That means it is clearly here, you can go in this direction or in this direction. The number of terms in AP, that is 0, 8, 16, 256 will be number of integral terms. It will be number of integral terms. And what is the number of integral term? Therefore, number of integral term कितने होंगे? It is, we can directly say 256 is there, so we can divide 256 by 8, and for the 0, you have to add one term. So it is 32 plus 1, so it is 32 plus 1, that is total 33 terms will come there. So answer is total 33 terms for this.